Hello and welcome to the CyVerse Focus Forum webinar on VICE, which stands for Visual Interactive Computing Environment. Morning, everybody. Today's webinar will be approximately 45 minutes long, and it's a presentation and demos with about 10 to 15 minutes for questions at the very end. So please hold your questions. Before we start, a bit of housekeeping to take care of. If you haven't already, please shut off your video. Also, be sure to open the chat window because that's where you'll type in any questions that arise during the presentations, and I'll read those at the end and we'll be sure to address all of your questions. A video of this webinar along with the slides and other materials, the documentation, will be listed on a wiki page, and I've typed in on the chat window the link to that wiki page. I'll also send you that link as well as a survey after the webinar to get your feedback on how we've done and any other feedback you'd like to give us. And then last but not least is be sure to mark your calendars for the 2nd of November when Ramona Walls will be giving the next Focus Forum webinar on making your data fair with CyVerse. This webinar is intended to help anybody who's intending to publish data or is publishing a paper based on data, and it will help you make your data conform to the FAIR principles. If you're not familiar with FAIR, FAIR stands for findable, accessible, interoperable, and reusable. So without further delay, I'd like to introduce today's presenters, Tyson Swetnam, Upendra Devasetti, and Corey Hirsch. Upendra and Tyson are science informaticians here at CyVerse, and Corey is an assistant professor at University of Minnesota. So Tyson, you're up.
All right. Thank you, Tina, for that introduction. Welcome.
The hell?
Hold on.
You all right?
Sorry. Yes. Please start over.
Okay. Well, welcome everyone, and thank you for tuning in. We're excited to show VICE, which has been in development for the last couple of years, and it's finally ready for the community to use. For those of you that are unfamiliar with CyVerse, we're an NSF-funded cyber infrastructure project in the life sciences. Our vision is to transform science through data-driven discovery, and our mission is to design, deploy, and expand a national cyber infrastructure for life sciences and to train scientists in its use. This diagram lays out the structure of CyVerse. We are built around a large, scalable data store where scientists can place their data. They can access that data through multiple types of clients, be it the command line, web browser, desktop client, or programmatic API. CyVerse hosts its own cloud service, which we call Atmosphere, so that you can do work on your data. We are also connected to high-performance computing through the Exceed network and computational grids like the Open Science Grid, so you can run jobs on those as well. CyVerse has a powered by product where we provide parts of the infrastructure. For an example, if you needed a security, you can use our OAuth. If you'd like to use our data store, you can use it. Or if you need access to compute, we can connect you through that. You can also publish your data using CyVerse by putting them into our data commons. When you put your data in there, we can give it a digital identifier number or a DOI, and then you can place that in your publication as a supplemental. Today we're going to be talking a lot about our discovery environment, which is our data science workbench. It's accessed through the URL de.cyverse.org. The DE is several years old now. It was initially built to run command line applications so that you could run large jobs on distributed environments like on HPC. And the way that you do this is you provide your app or your tool as a Docker container, and we place it into the DE. You can then add your data to the data store, and then when you run your job, you can select the typical command line flags or parameters. That job starts, it runs till completion, and you're notified when the job is done, and you can view those analysis results. What we now have with Vice, or this visual interactive computing environment, is essentially an extension of the discovery environment, which provides a graphic user interface. And we're using this same platform, Docker, to containerize the apps, but you can now do it graphically. And the way that the user accesses their app is through secure and authenticated URL, or the HTTPS protocol, and you can use your favorite browser to do that. For anyone that's been following the news lately, you often hear about the problem of reproducibility in science. This issue where we publish our work and then others try to reproduce our analyses and they can't do it either because the data aren't there, or the analysis tools that we use aren't available, or the code we used weren't there. And when you look at the landscape that's available, we already have these things in place. We have version control systems like GitHub or GitLab. We have ways of containerizing our software, which can take care of dependency problems using platforms like Docker. There are hosted web app services like shiny.io or mybinder.org, where you can run these analyses and you can bring your data to those, and those run on supported hardware. But there's an issue. So over time, you can see that a version can change in a VCS, or a dependency is updated. And if that breaks down, then that hosted application may no longer run. Further data can be moved, or they can be shifted to another location. And if the URL isn't updated, that application will no longer run. And if you're trying to do really large analyses that require things like HPC, then the hardware that's available through these hosted services may not be adequate to be able to rerun those analyses. So if any one of these steps breaks down, then that reproducibility goes away. When you look at the NSF data management requirements for research now, this is from a recent Plant Genome Research Program data sharing and management requirement. You can see that all software must be versioned and put into a version control system like GitHub, and it needs to be released when you publish that research. Your code needs to be well documented so that others can reuse it. And the NSF is suggesting that you include an integration with a computing resource like the Galaxy project or with CyVerse. And the way that you can do this is you can run it on a virtual machine. The examples that are given are the Amazon Web Services, or even CyVerse's Atmosphere, or its sister product Jetstream, which runs on the Exceed framework. And then you need to be able to run these analysis using things like containers, and they suggest Docker or even possibly Singularity. So if you think to yourself, where are your data? Are they in a place where your collaborators can access those data? What about the readers when you go to publish? Will they be able to access your data and reproduce your analysis? Further, when you go to process your data, are you going to be able to run that on a laptop? Will you need additional compute resources like HPC? And then further, if people want to reproduce your analysis, are they going to have access to the computational resources required to reproduce that work? And then last, are your data in a secure place? Will they be safe if they're ever lost or changed? And can you provide that security for other users to come in and access those data? I want to shift gears a little bit and talk about the growth of these different programming languages that are out there for doing data science. Today we'll be focusing primarily on two different languages. On the left-hand graph, you can see the rise of Python as one of the favorite languages to program in. And on the right, you can see the use of R for statistical analyses. And so R and Python have kind of come out front as the winners for data scientists to be working in. Also, this idea about working in what's called a computational notebook. And a notebook is essentially like a text file, but it allows you to write code and then to document that code with text. You can even write things like equations. And this recent Nature article talks about the rise of Jupyter notebooks as the computational notebook of choice for data science. Part of the reason that Jupyter has become so popular is the ability to integrate virtually any computational language kernel into a notebook. And so these are just some examples of the available languages that are in Jupyter today that you can go and you can create a notebook using any one of these languages. Similarly, the R group has produced a platform called RStudio, which is an integrated development environment. We have a screenshot of the RStudio running in our Vice environment there on the lower right. And this is a nice interface where you can look at your notebooks, you can look at your data, and you can run analyses. The R group has also created an application called Shiny, which is a web app for building applications in the R language. And this is nice because you don't have to learn how to write HTML, CSS, or JavaScript code. You can create a web app in R, which is probably familiar to you if you're an ecologist or a life scientist. Similarly, you can run web applications using things like WebGL or Nginx. On the right, I have an example of some LiDAR data, which was collected by the National Ecological Observatory Network. And we're displaying this in a WebGL application called Potree. This is an open source app. And Potree is pretty cool. You can display up to trillions of points at a time through a browser. More typically with individual LiDAR collections, you're looking at billions of points. This particular example has a few billion points in it. And so you can run these through the Vice as a web app. And so when we think about what Vice provides for us now is that we can containerize our applications, which gives us this portable interface that we can work on. We're taking a Lego block approach where you can select your specific package or environment that's unique to you. And this helps ensure this reproducibility that we need. One more example about running the Vice applications in the discovery environment. If you or your collaborators are creating notebooks, either in an IPython notebook or an R Markdown, and then hosting those on a version control system, you can move those data into our data store and then launch your Vice app using that notebook at the time that you launch it. You can move your data into the data store using one of our tools, or after you've launched your Vice app, you can move those data into the running application. So at this point, I'm going to shift gears, and I'm going to let my colleague Upendra Devasetti take over and give you all a live demonstration of Vice.
Thank you, Tyson. My name is Upendra Devasetti, and I'm a science informatician working in the same project as CyVerse. So now that Tyson has introduced all about Vice, in the next 20 to 25 minutes, what I'm going to do is to give you a brief demo of how Vice works inside Discovery environment, and also tell you a little bit about how you can build one of those Vice apps if you're a developer or if you have a tool that you're interested in bringing that inside Discovery environment as Vice. And in the last couple of minutes, Corey Hirsch from University of Minnesota will demo how he has used the Vice environment for integrating into one of his plant phenotypic pipeline. Okay, let's get started. Okay, so I'm gonna switch tabs, and then I'm gonna go and show you my Discovery environment. And for those of you who are new to the Discovery environment, as Tyson introduced, Discovery environment is our go-to platform for doing bioinformatics and data analysis. And the only thing that you need for accessing Discovery environment is an account with CyVerse, and registering for CyVerse has no cost, so you can register, and when you register, you get free access to the Discovery environment. And here is a dashboard of Discovery environment, and you might see that Discovery environment has a very clean dashboard compared to the other platforms available. The three things that you see when you log into Discovery environment are the data window, apps window, and the analysis window. Since this webinar is not about Discovery environment, I'm going to skip most of the steps that are involved in explaining more about Discovery environment. So to get started using the Vice apps, the first thing that you would be doing is to click on this apps window, which will open an apps window. And in this apps window, what you see at the top is the search bar, where you can use this to actually search for the app that you're interested in. So currently there are 3 Vice apps that are available for users. The first app that I'm gonna demo is the Jupyter Lab app. So let's search for Jupyter Lab. Okay, so when you search for Jupyter Lab, what you see here is the Jupyter Lab app. And in future, probably there'll be more versions of the Jupyter Lab. Like if someone wants to use this as a base image and then make a new app, then you'll have more of this. But we will document like what version of the app corresponds to what feature that it includes and so on. So let's quickly open this Jupyter Lab app. And again, if you're new to Discovery Environment, there are a couple of things that an app consists of. The first thing is at the top panel. The top panel basically includes some of the metadata about the app. For example, analysis name, comments, and output for the default output folder location. You can change all these parameters, or you can leave it as it is. For this demo, I'm gonna rename this as Vice demo. And then the second panel basically consists of the fields that corresponds to either the files, directories, checkboxes, and so on. In this case, there are 3 fields, and each field corresponds to the directory that the app needs. For example, the first field is a data directory field, and the second one is notebook directory, and the third one is iDocs configuration. Ideally, this app requires that your data should be kept in a separate folder compared to the notebooks. But for the sake of this demo, I'm going to use the first field, which is the data directory. And on my right, I have example data that I'm going to use with all the Vice apps. And if I click open the Jupyter Lab, what I have here is 2 notebooks, Iris Species Dataset Visualization Notebook and Machine Learning with Iris Dataset Notebook, along with the data, iris.csv. So I'm gonna go ahead and drag and drop this folder into the data directory field, and then I'll say launch analysis. And once you click the launch analysis, the first thing that you'll notice is the message saying that the app has been submitted, and the second message that you see most of the times very quickly is this access your running analysis. So if you're used to using DE for normal analysis, this may seem a little bit different from your earlier analysis, because the earlier analysis just says it's running. But since this Vice apps runs on a browser, so you have to open it in a browser. And the way that you can do it is by clicking this, the URL, access your running analysis here, which should open a Jupyter Lab in your browser. And again, if you're not used to Jupyter Lab and if you're used to Jupyter Notebooks, no worries. Jupyter Lab is this interactive environment which is nicely organized into 3 different tabs. The first tab is the Notebooks tab. Currently, we have Python 3, Julia, and R. And then in the console, we have the same programming languages corresponding to those to the notebooks. And the third tab that you have is the terminal and text file. On the left, what you're seeing here is the input folder that we used at the time of launch. For example, the first folder that we're seeing here is the same folder that we used at the time of launch. And in that folder, you have the 2 Jupyter notebooks along with the data. So if I click open one of these notebooks, what you see here is the Python code corresponding to the visualization of the Iris data set. So the only thing that you have to do is to go ahead and start running this notebook. And then you'll see the notebook runs. Since this notebook already addresses all the dependencies that your notebook needs, so it's just you just need to go ahead and run your analysis without having to worry about figuring out all the dependencies. And if you have to install any further dependencies, so the Jupyter Lab also consists of the terminal, and if you click open the terminal, then it provides you the command line interface for installing any of the dependencies that are needed. So for example, if there's a dependencies like Java that needs to be installed, then you can use this Conda package manager to install that. And if you need any other dependencies that are not part of the Conda, then you can use pip. One more thing that I want to talk about Jupyter Lab before I switch to the other Vice apps is the second tab that has the CyVerse logo. This tab basically gives you access to the data store inside your Jupyter Lab, and for that one you have to do a few things. First, you have to initialize the data store. The way that you can do is to enter certain fields, and the details of all this you can find it in the CyVerse wiki. And then I'm gonna enter the port, and then the username is my username, and zone is iPlant, and the password is okay. Maybe I'm getting the wrong password. Let me try. Okay, I think I entered the wrong password. Anyway, so once you enter these details correctly, then you should be able to see the file browser in here. Okay, so that's pretty much about the Jupyter Lab. Let me show you the other two Vice apps that we have. The second app that we have is the RStudio app. And again, the way that you can search for RStudio is by entering the keyword RStudio. And then click open this. Again, the launching of this Vice app, RStudio Vice app, is similar to Jupyter Lab in that we provide you two tools. One is the individual input files that you can drag and drop. The other one is if you have a folder that you just want to drop and drag and drop. And for this demo, I'm not gonna go and launch the actual analysis, because I already have a running analysis that I want to quickly show you. And the way that you can access your running analysis is by clicking this, the third window that you just saw so little earlier. So I have this running analysis of RStudio. So if you want to access that, so you can click open that. And unlike Jupyter Lab, RStudio requires that you have to enter your username and password. So the username and password for this is RStudio and RStudio. Okay, so if you enter those credentials correctly, then you would see the dashboard of RStudio, and most of you are already familiar with RStudio, so I'm not going to go into the details. And what I want to point out is the folder that we used at the time of launching is available for you to look at the fourth window. And if you click open that, currently there are two files. One is the R notebook, and the other one is the file. Again, similar to Jupyter Lab, if you want to start running, then you can just go ahead and run each block separately, or you can run the whole notebook by clicking on this run all, and it should take a few seconds for it to finish. And eventually you would see all the output files and the plots that corresponds to the R notebook. And yeah, again, yes, as you can see here, I generated the plot, and on the left in the console, you see that there's some error messages, and this is the powerful feature of the Vice app, where you can see all the errors that you have, and then you can fix it right away. Whereas unlike non-Vice app, you have to wait for those apps to finish before you can actually know what is wrong with your analysis and so on. So that's about RStudio. And the final Vice app that I'm going to show you is this Shiny app. Again, okay, the Shiny app, unlike other apps, requires that you, let me quickly show you how you can actually start with the Shiny app. So search for the Shiny app. And then again, similar to RStudio, it has these two fields. One is the multiple input fields, and the other one is the input folder. And And for this example, I'm going to use a folder that consists of some R code. That R code corresponds to the Shiny app, and also have some examples of the input files that I want to display. So let's quickly drag and drop this folder in here, and then say launch analysis. And it takes a couple of minutes for it to get ready, and then you can start using the Shiny app. For this example, I already have a working Shiny running. So if I click open this, the file browsing, what you see here are the two input files that are part of my initial launch. So if I click one of this and then say select, and this is a very simplified Shiny analysis. It basically shows you the options that you want your table to be displayed. For example, I want to display my table based on the comma and based on double quote, and then I want to show the first 6 rows of the file. And I can also do this. I can say show me all the rows in the data frame. And for this one, I'll just. And the other thing that you see here is the summary, and the third one is the plot. And the plot here takes a little longer because there are too many data points on this. And as you can see here, and if you were to do the same thing on a Shiny apps.io on a Shiny server, it takes a lot for the server to accommodate this kind of analysis, because the input data that we have is currently around 1 GB. So I have another example where I have a big file of 1 GB, and then if I click open this, and then if I say all, you would see that there's 20,000 entries. And if you were to do the same thing on an external server, it takes a long time because the server doesn't have enough memory to actually show everything. And I'm not going to click on the plot because the server will break down because there are too many data points. So I have to optimize my code to plot not that many points. Okay, so that's pretty much about the 3 Vice apps that we currently have. And let me quickly switch back to my demo, to my presentation, and then show you how actually our device ecosystem looks like. So here is a high-level overview of the different components of the Vice ecosystem. At the back end, we have technologies such as Kubernetes, Conda, Docker, and other high-level technologies. And in the center is the Vice. And the Vice is nicely integrated with the data store and then the computation. And as I said, currently we have 3 Vice apps that are publicly available: RStudio, Shiny, Jupyter Lab. We also have VNC and Guacamole, but they are not publicly available. If you are interested in that, please get in touch with us, and then we will give you access to that. And as you would realize by now, that you can bring in any web application, not only restricted to these 3, like RStudio, Shiny, and Jupyter, and integrate into Vice. And the other good thing about Vice is there's no restriction of how you can access the Vice. You can use the PC, Mac, Linux, you can use also Chromebook. And the only thing that you would need is an active internet connection and an account with CyVerse. Okay, the last few minutes, I'm gonna tell you how you can make a Vice app. And as I said, like the 3 Vice apps that we currently have in DE are sufficient for most of your data analysis needs for R and Python, because those are based on popular Docker-based images in Rocker and Jupyter Data Science Notebook. And as I said earlier, there's plenty more Jupyter Lab-based Vice apps, mainly to deal with metagenomics, machine learning, and GIS, and also RStudio for bioinformatics and next-generation sequencing like bioconductor and GIS, and also web apps. They are yet to come in near future, probably in a couple of weeks, because we are actively working on that to make them available for users to use them. And if you think that the current Vice apps and also the future apps doesn't meet your requirements, then you can always request your Vice app or the tool that you have to be integrated into DE. And there's a simple tool request form that is available in the DE, which you can use. And the workflow for making Vice apps is pretty straightforward and easy. It only involves 3 steps. First, you have to create a Docker image. And again, this is mainly for the developer. And if you're a normal user who is interested in using Vice apps, then you don't need to bother about making a new Vice app. And the second requirement is you have to create a tool JSON. Again, you can use a template and then modify a few fields in the template to suit to your Docker image. And the third one is you can create an app JSON, or you can use the drag and drop feature in DE to design an app. And finally, you submit the Docker image along with the JSON to us, and then you wait to hear from us, which will in those 2 days we will review and integrate your Vice app. Here is an example Vice app. So this Vice app is based on RStudio as the base image, and this is a sleuth Vice app. The sleuth, for those of you who haven't heard before, sleuth is a differentially expressed package that is mainly used by next generation sequencing folks. And the first step is to create a Docker image. And for creating a Docker image, you need a Docker file. And here provided an example of how I create a Docker file. And the one tip that we highly recommend is to use a community Vice image. And the second step within the first step is build your Docker image. And you can use the automated build, and we provided the links of how you can do that. And the third step is test your Docker image. Again, don't worry if you are not used to building Docker images. We have provided the links where we detailed each and every step to definitely help you to build one. And again, as I said, if you are not intending to build any new Vice app, then you don't have to worry about building one. And the second step is the create the tool JSON. Again, tool JSON, you can use the template and then modify a few things to suit to your tool. And the last step is to use the drag and drop feature in DE to create an app. And that's pretty much it. And with that, I would like to welcome Corey Hesh, and he will tell us a little bit about the Vice app that he has developed, and he has integrated in his phenotyping pipeline.
All right, thank you. Can everybody hear me okay?
Yes.
Okay. So there's a lot of animation, so you can just zip through, and I'll just describe the slide then. So this is work that has been developed with Edgar Spalding and Nathan Miller at the University of Wisconsin-Madison. And so my lab is really interested in studying plant responses to stress. And you know, a big tool that we use now is plant phenotyping and high throughput phenotyping. And so we wanted to develop a way for multiple groups to acquire standard images for plant responses. And this gives us a lot of data then that we can analyze. So this is kind of an outline of a pipeline that we developed using CyVerse's infrastructure and tools. So it starts off with simple, just a camera and a background that we take images of plants. That's all run automatically through a computer, and it's standardized that we have scripts that then make sure that our focal length is set the same, our exposure times, things like that. Are set the same. And we've also developed a QR code that can be put into the image that we can then, the software that's been developed with Nathan Miller can read that QR code, and it's really for metadata standardization. And so that data we can acquire in our labs, and then that automatically gets pushed up to our data store in CyVerse. And then once on CyVerse, then we can do all of our image analysis tools. And so that software has really been worked through with Nathan Miller, and he has this Phytomorph image phenomics toolkit. And we have methods now and software built into the CyVerse infrastructure to look at different morphological traits that you can see that we can extract from the image. things like center of mass, mass distribution, width, height, different morphological traits of the plant. And really that leads us then to a data analysis step, where we have lots of data points, lots of plants, lots of time points, and then we look at the data analysis. And so we've developed this really around the CyVerse infrastructure, previously really just leveraging the discovery environment. And so it's kind of why I have that gray box there showing, those were the tools that we could use in CyVerse originally. And so we're kind of missing that last step of our pipeline was part of that data analysis. So you can go to the next slide now. So then now that the Vice tool is now available, we're actually able to do a lot of our data analysis on CyVerse within our discovery environment now. So these are just two screenshots of a Shiny app that we've developed to look at sort of the initial quality control of images, to do some plotting, look at data, things like that. At this point, that's where we're at with this. So this has really been developed in my lab and a very talented undergrad, Roman Woodward. And this is really allowing us now to really use our entire pipeline on CyVerse. From once we acquire images in our lab, they automatically get put up onto CyVerse. We then, and the traits get extracted from those images, and now we can start to do these analyses. So it's really a full pipeline now. And so we're able to store data. We're able to access that data that's on CyVerse. We don't have to do all these transfers down to local drives anymore. All of that is taken care of for us already. And so one of the last things that this is really helpful for us is that this is a collaborative effort from a couple different institutions. A couple different groups at the University of Minnesota here are running this pipeline. And there's also a group at the University of Wisconsin running this pipeline as well. And so this has really allowed us to share our methods and tools a lot easier and make sure everybody is running the same pipelines, has the most up-to-date code, up-to-date analysis techniques that we're doing. This is really allowing us to do that now. And like I said, we don't have to transfer data anymore. Data can be shared between groups. They can then analyze all of that data themselves now within the Vice environment, or using these Shiny apps on CyVerse. So that's really what we've been using this for. We really think this is a really nice tool. If people are developing Shiny apps for your labs, this is really a nice way to leverage some infrastructure at CyVerse to sort of help you do research and get that out there to the community a lot easier.
All right, great. Thank you so much, Corey. Okay, so just to review, some of the technologies that we're using inside of Vice include the Apache Zeppelin, our Studio, our Shiny, Jupyter Notebooks. You can run WebGL applications and things programmed in JavaScript. And these problems that we're trying to address include the ability to now install Vice apps so that you don't have to do this on your local machine. It's less technical, so you don't have to use the command line. We have the ability to essentially launch apps from a button. We're providing data hosting through CyVerse, which is running on large enterprise hardware, including HPC and grid computing. CyVerse provides security through our OAuth system. You have privacy by setting privileges so you can view your data. You can share your data with your fellow lab members or with the community. And we're also giving you that hosting service for your web applications. Some things that users should consider about Vice. One is that we must be able to containerize your application. So we need to have a Docker recipe file. There are issues around launching proprietary software. We can do it in special cases where you can share that software with your collaborators or your team, though you cannot make those apps public per the user agreements with those software. Currently, the Vice is limited to a 48-hour runtime after you've started your container. But we will note that in the near future, you will have the ability to modify the duration of that. You will also have the ability to increase the number of cores or RAM which you'd like to run your application on. as well as the availability of a GPU. And we're targeting all of this for a December release. And I'd also like to point out that we're having some future webinars. We have, I think, oh, there you go. Sorry, I skipped a slide. I thought I skipped one. Okay, so as you can see, there's a lot of work left to do with Vice. We're pretty excited to have this initial release, but there's other things that we'd like to do. First, we'd like to get the GPU Vice applications online. We're looking into launching Singularity containers in Vice rather than Docker containers. Combining applications so that you can launch in workshops or run courses. We're looking to add a button or badge which you can include on your GitHub page, similar to what you can do currently with mybinder. Doing multi-node launches, so for example, using a Spark or PySpark cluster, similar to what you can do currently with the Dask environment. Using version management for your applications. We have documentation which you can visit at our DE manual. We'll be teaching another container camp. Our first camp was this last spring, but we'll be teaching a camp on building your own container in Docker and Singularity in 2019. Deploying your own working environment through a unique RStudio or Jupyter Notebook, which could include dependencies which aren't currently in the base hosted images we have. And then providing some best practices for Vice applications. Additional webinars to look forward to are using Docker to build your own Vice apps, building your own Shiny apps to launch in Vice, and then how you can do more with your Jupyter notebooks. And so I think at this time we'd like to stop and take some questions from people. So Tina, if we have any questions, people can put them in chat or they can ask to be unmuted.
Okay, Sam Roy has submitted a couple questions, and I think you addressed the first part of that already, but I'll read the question. Can you keep a CyVerse app persistent, or is there a wall time or set time to free resources as needed for other apps? I believe you covered that, and it's currently 48 hours.
Yeah, so one point about having the app is persistent. So because we're hosting your Shiny app in the data store, whenever you need it, you can come and turn it on, and it will run for 2 days. But it's not just running all the time.
Okay. The second part of his question is also, how can you change max core and memory in tool JSON files?
Yeah, so those can be changed in the tool JSON file when you create the tool. And as I said, in the next release of Vice, we'll have the option directly in the discovery environment for you to modify that when you launch your Vice app.
Okay. I don't see any other questions at this time. Do people have questions? If so, please type it into the chat box. That's the best way to get your question answered. And again, if you have any questions when you're actually in Vice, we do have a support tool called Intercom where you can basically ping us and get some fairly quick help right away. So that's another way to reach us if you have questions. All right. Okay, you can also, okay, there's another question. What about package management in RStudio?
So when you launch RStudio, you can install packages doing the normal install packages command. If you have additional dependencies which are based out of the Linux kernel, so for example, GIS dependencies like GDAL, you'll have to build a new image for that. And one thing that we are working on is the ability to allow users to have root authority in the Docker container. This is one of the well-known problems with Docker, is that you can't provide root privilege to people because they can do bad things to your system. So currently in our RStudio framework, we have the base package, which you can install, I think basically anything which is in the Conda environment, and then any additional R packages. But anything that's base Linux, you would need to build your own additional RStudio image. And
yeah, so just on that note, so I just want to switch back to the presentation where actually I talked a little bit about that, but I was rushing because we didn't have time. So here is an example that basically uses the the existing the base image as the existing community image as a base image, and then installing the packages that are not part of this base image. In this example, the dev tools and the sleuth are not part of this base image. So what I did was I used the community image as a base image, and then I included all the dependencies and along with all the packages that are needed for running this sleuth. And then I built the image, and then I tested it, and then I created a tool JSON, and then I built the sleuth app. So this is one example of how you can manage the dependencies as well as the packages that are not part of this community Vice app.
I can see there's a new question from Mustafa. So are the packages installed by the user persistent? You want to answer that?
Yeah, so this is one thing that we are currently working on. Right now, all the packages that you install in that cannot be saved, and the other limitations currently with the Vice apps is it is only active for 48 hours. So if you want to use more than 48 hours, then you have to request us, or you have to launch a new one and then install everything into that. So in the next couple of releases, we will have a system where you can freeze the entire environment, similar to how we do that in the atmosphere. In that way, once you freeze it, then you can make a new image by freezing it, and then you can use that after 48 hours if you want to keep using that, which includes all the packages that you install in the initial launch.
Okay, so several more questions from Priya Roy. So if you have a process running, is it possible to extend the wall time if the app is still running and I guess it's running out of time? So I'd say no. Currently, once you launch that app, you have a 48-hour window. As I said, in the December release, you'll have the option to extend that runtime. So the data volumes are being written into the container, but if you write your code so that you do, say, an iRods IPut, you could be writing your results back directly to the data store as the app is running.
Yeah, so there's one more thing in that relation is like once you finish running your analysis and once you save your analysis and then quit it, all the data that you generated, like the output files and the plots, will be brought back to the data store in that analysis folder specific for that app. So you don't have to worry about downloading the outputs that you generated during that analysis onto your computer. They will be brought back once you cancel your analysis, once you save your analysis. And also once you exceed your 48 hours, then all the outputs will be brought back into the data store. So you won't lose anything even if you exceed 48 hours.
Okay. Is it possible to integrate webhooks into an app setup? So depending on the app, I would say yes. Yeah. Okay, CK Chan has a question. Is it possible to use GPU in Vice? And the answer is it will be. Once we add our GPU nodes to the Vice cluster, we have those nodes in existence and they are being tested right now. The next question from Satish is, does Jupyter Lab come with IR kernel so as to run R scripts in a Jupyter notebook? The current Jupyter Lab container does not have the R kernel, but we could add it for you today, and we can have a new R kernel available in the Jupyter Lab. And then, let's see. Sam has another question. Does freeze save environment variables and sys variables as well to the image? So, for example, passwords or API keys. So the way I would approach that would be that you would create those API keys, or you not necessarily want to save passwords, but you could create files in your CyVerse user account where you're storing that API key, and you pass that into the container when it's run. Oh, I'm sorry, it does. So apparently we do have the R kernel already installed, so we don't have to install it for you. It is there already. I think one thing that we forgot to show was the ability to share a Vice application while it's running.
Yeah, so let me quickly do that. So as you already saw that there are some analyses that are running. So now I would like to share this with my colleague or a collaborator that I'm working on so that we can both work on the same thing. So I'll quickly select the analysis that I'm interested in sharing with. And then if you go to analysis tab and then say share with collaborator, then you either enter the username of the person that you're interested in, or you can also quickly enter the name of the person, the full name, and then it should come up because we already save all the usernames in a database, so you should be able to see that. And then if you click done, the person will get a notification saying that this analysis has been shared with you, and if my colleague clicks that link, then he should be able to see the same thing that I'm currently running. So this is one powerful feature of the BICEPs that is not found anywhere else, and both the collaborators can work on the same analysis at the same time.
Okay. So we have a question: is it possible to launch a new notebook without data? And yes, you can launch your Vice application without any data in it once it's running. So, for example, if we're running in a Jupyter lab, we could then open a new terminal window and then do something like a git clone or a wget command to bring those data in. Or we could use iRods and do something like an iget to bring those data directly from our data store.
Yeah, so as you would see that none of the fields in the app are mandatory. That means like it's not necessary that you should fill the fields with either the files or the notebooks. So you can just launch the app without any input files, and then you get a clean RStudio or Jupyter lab where you can use the consoles or the terminal to start running your analysis, and then use terminal to bring the data inside the Jupyter lab.
Okay. So with that, we are approaching the end. We have another question, looks like. Will the service be similar to counting the standard units or the allocation units for CyVerse, Atmo, or Jetstream based on the Docker setup? So currently right now, no. You're able to run Vice without adding in any additional AU to your allocations.
Okay.
Well, thank you everyone for tuning in, and I hope you guys try out Vice. Maybe in the chat window, if you're paying attention, could you let us know if you've already launched a Vice app while we've been talking? To see how many people raise their hands. But thank you very much.
Are you all able to hear me?
Yep.
Okay. Thank you, Tyson, Upendra, and Corey. That's been great. You guys covered so much, and there are a lot of good questions. One correction on my announcement earlier, the next webinar is November 30th, not today, and that's the one on the FAIR data with CyVerse. And in the meantime, if there are any further questions, let's see, let's notebook. Okay, I think we're good. And so thank you, and stay tuned for announcements and information on our website about the upcoming webinars, and we'll see you next time. Thank you, everybody.
Actually, I would say one last thing is that we have developed documentation for Vice, which you can access through learning.cyvers.org.
And a link to that will also be on that wiki page that I'll send you all the link for. Thank you, everyone.
Thank you.
Thank you.
Have a good weekend.